Hello, y'all. Welcome to Acids and Bases units. We're going to be looking at pages 3 and 4 today. Okay, something that's written on my board as a key concept is this little memory device, big blue bitter base, because bases will have a big pH, it's over 7. They will turn litmus paper blue or keep it blue. They're bitter to the taste, and that's how you know it's a base property. Okay? So if it's bitter, we know it's going to be base. For number 2, sour, that's think of your citric acid, your ascorbic acid, those types of flavorings that are added to sour candy. And electrolytes, there are 3 types of electrolytes we're going to focus on this year. And that's ionic things from last unit, acids and bases, so they are both electrolytes. And I want to look at this last one. A substance that turns red litmus paper blue or causes no change to blue. So it either turns blue or stays blue. That's the big blue bitter base. Okay. This section right here is reviewing what we went over on the homework on pages 1 and 2, naming and writing formulas for acids. So I just wanted to remind you this process, if it begins with H, that's the Arrhenius definition. Okay, it's an acid. If there are only 2 elements in it, then it's a binary acid, so we call it hydroselenic or hydrochloric acid. And if it's an oxyacid, if it has a polyatomic ion, we are not allowed to say hydro. We'd say chlorite becomes chlorous acid, and chlorate becomes chloric acid. Those are the rules. Okay? So if I'm looking at this one right here, HNO2, I know it's an acid, so I'm going to call it something acid. And I am not going to call it hydro because I see there's a polyatomic ion in there. Okay? It's not binary. There's more than 2 elements, so I'm not allowed to say hydro or over here. So I need to look NO2 up on my polyatomic list. NO2 is nitrite, and bites are delicious. So I'm going to call this nitrous acid. Okay? Nitrous acid. Coming over here, which other ones do I want to look at with you? This one. Let's do the formula writing for aluminum hydroxide. Now, this is a base because it ends in hydroxide, but this has also been on your tests and homework since October. Okay, we've been doing 4-step formulas like this. So, aluminum symbols Al, hydroxide symbol OH. Okay, so that's step 1. Symbols and then charges. Crisscross. Reduce and erase. So Al, invisible 1, OH, 3. 4-step formulas. Okay. Naming, the only trick about naming that we have to be careful with is the exception block. Okay. So remember, there's the 1 in 1b that always makes a +1 charge, the 2 in 2b that always make a +2 charge, and the 3 in 3a that always make a +3 charge for our purposes. So this exception block never gets Roman numerals when we name. We also learned first semester that family 1 always makes a +1 charge and family 2 always makes a +2 charge. So these guys never get Roman numerals. Okay, so of the metals that I'm showing you, they all need Roman numerals except my blue little staircase. So iron over here is definitely going to need a Roman numeral in its name. Iron, and then OH is hydroxide. So I'm going to say iron blank hydroxide. Okay, now to find the Roman numeral, we need to uncrisscross. Iron has an invisible 1 after it, and there's a 2 back there. So I check, and hydroxide does make a -1 charge. So that means this iron must be making a 2 charge. So I'm going to call that iron 2 hydroxide. Looking down on the bottom half of this worksheet, we're trying to decide if this is a dissociation of an acid or a base. Remember, dissociating is dissolving with a charge, which means it's an electrolyte. So the key thing to look for would be the hydroxide ion tells me it's base. Okay? A hydrogen ion or a proton like that tells me it's an acid. Okay, so that's what we're looking for. And then over here on the pH scale, Remember we said big blue bitter base, so the pH of 0 to 7 to 14, that's my pH scale. Where it's big is where it's a base, where it's little is where it's an acid, and then neutral is if it's exactly 7. So bigger than 7 here, I would say base. Small, I'd say acid. pH of 1 is very, very acidic. Good. All right, let's turn over the page. See what we have back here. Okay, check your notes on this one. These are things that need to get memorized, so I don't want to give you those words. I want you to look them up in your notes. For 27, we're looking at acid-base properties. Okay. So I wanted to look at some of these ones with you right here. If it has a bitter taste, big blue bitter base, that'd be basic. If H plus is less than OH, that means I have less acid ion and more base ion, so I must be basic overall. If the pH is greater than 7, base. A proton acceptor, okay, that's a Bronsted-Lowry base. Okay, and turns blue litmus paper red. There's our acid. Okay. Check your notes if those are a little rusty. Okay. I'm going to let you guys practice on the naming and stuff. If you need more help with the naming, please make sure you are checking out the video tutorial for pages 1 and 2 for acids. Okay. Good job.